In this video, I break down the solution for challenge number 7, force of Ethernaut CTF. In this channel, we share all the solutions for Ethernaut CTF and others, so stay tuned for more. I also explain the reasoning behind the solution so that everyone can understand it, learn, and do it themselves too. So if you like this kind of stuff, you're in the right place. Hello, and welcome to DecentraWise channel. My name is Pedro, and here we share all things Web3 and blockchain development and security. So if you are the nerdy style, you are in the right place. So let's dive right in. And we are at Ethernaut CTF here. If you want to know how to connect MetaMask to this and everything, head to our first video in this series where we talk about that. For this, we need to open the console to be able to interact with the challenge. So let's go to challenge number 7. It's force. There we go, and it's this challenge. So we have our addresses and so on, and everything is good to go. And what do we have here? What do they say to us? Some contracts will simply not take your money. And the goal of this level is to make the balance of the contract greater than 0. Okay. Hints that they say to us. Fallback methods. Sometimes the best way to attack a contract is with another contract. We've seen that. And so it seems that we will need to develop a contract. But how will we be able to send money to this contract? Because it's Solidity number version 8, 0.8, and it has no receive function, and no fallback function that is payable. So in theory, this contract couldn't receive money, and that's what this challenge is all about. But that's not true, because there is an exception to this. And if you don't have a drink, grab yours. Mine is coffee, as always. So if we have something like this and we rely that the contract will never receive money, if not much bad things can happen, it's not a very problematic thing. But we cannot rely on this being true, because there is an exception to all this, which is the self-destruct. Okay, I know it's being deprecated and so on, but in the meantime, it is still working self-destruct. So whenever you self-destruct a contract that has money in it, it will send the money to the address that we supply in the self-destruct. So what does this mean? This means that it is an on-chain faculty that money those coins will be transferred so that we can self-destruct the contract and the balance will not be wasted. And it's cool, but since it is on-chain directly, it doesn't go through any of the fallback functions or receive functions or whatever. So we can send money to this contract with the self-destruct contract. So let's jump in and build that thing. So how can we do that? We need to go to Remix. So Remix IDE, it's remix.ethereum.org, and you have something like this. So here in contracts, we can create our own contract file. So let's create, this is force. So force.sol. There we are. We have a force.sol contract. Let's copy this thingy so that we don't have to write it all down. There we go. And we have our force attack contract. I love this name. So now we need to store the address of the victim contract somehow. So let's do it. Let's do address public or whatever victim. It's our victim. And let's have a constructor that sets this value. So constructor address victim and victim equals underscore victim. There we go. So we have a constructor. And now what we need is an attack function. So function attack. And this function is external, of course. And what will we do in this function? The only thing that we have to do is self-destruct ourselves, pun intended. So self-destruct, and we pass a payable victim. So we have here self-destruct has been deprecated. The underlying code will eventually undergo breaking changes, blah, blah, blah. Of course, we talked about that, but it is still working. So in the Solidity version that we are using. So we have this contract. Let's build it. We have a warning, which is the self-destruct deprecation, but it compiled anyway. So this is it. It's as simple as this. So let's try that out. Let's go grab our instance to play with and MetaMask, confirm, boom, we have our instance. It's this one. Let's copy the address, perfect. And now let's go to Remix and let's deploy our contract with the address that we got. Let's connect to MetaMask and do our thing. So we need to deploy some money along with the deploy contract. So we will send something. They don't say any amount, so let's say we send one way. It's enough. And we have here the deploy function. We put our address, victim address in the deploy, and we deploy the contract. Got estimation. Let's see what is the problem. One way. Let's put Ethereum Solidity version 8.0. It's probably the warning. So now we don't have any warnings. Perfect. Let's do the thing. So one way, deploy. Let's reload this. I don't know what's going on here. Open this again. Save it. It's compiled. Let's put one way. The address of the victim. Deploy. Okay, that's another thing. We need to put constructor payable and do it again. One way. Now it goes. Let's connect to MetaMask because it's what we need to do. Send one way and deploy. There we go. Now everything is fine. And boom, we have our contract deployed. It's in this address and it has the victim address correctly set. So let's attack it. There you go. There is an attack. You see that the balance is 0.00001 ETH. Confirm. And the balance is 0 ETH now. The contract was successful. So our contract is self-destructed, this one. And if we go to our Ethernaut and we check the balance of our instance, so let's await contract dot net. Let's do get balance instance and two strings so that we can read the thingy. and we have a balance, right? So let's see if we pass the challenge. Submit instance. There we go, MetaMask, confirm, and boom, we passed. We passed the challenge by sending one way to a contract that is not able to receive any balance. So this is it, guys. It's just this. There is only one exception when we don't think that the contract is able to receive money. It is, because self-destruct is able to send money to a contract. If we rely on the balance to be zero all the time, to do something in the contract, then this would be exploitable. So be careful with this. Don't think that contracts cannot receive a balance just because it's not true. So I hope you got value from this video. I hope you understood what's going on in this challenge. And if you did, go ahead and do the good things. Smash the like button, subscribe for more videos, because we are sharing all the time videos about Web3 development and security and all the good things. So thanks for watching, and see you in the next video in this series. Cheers. Bye-bye.